Yeah. Good afternoon. Welcome to a new program that we are trying to regularly conduct to discuss various issues that are relevant to our national benefit. So today, I'll just give a little introduction to where we are at the moment. We are trying to follow a principle where we will be a voluntary open forum. The purpose is basically to collect professional expertise that we have so much of in Sri Lanka, in home and abroad, and focus on the issues of national interest, and then consider proposed best solutions for national benefit. So we try to be more factual, evidence and experience based, and try to maintain a kind of a no blame culture. We'll call ourselves leads. Leads is a name you think, but actually it's a principle. We would learn, like what we are trying to do today, is from each other, share our expertise and evidence, and educate others, like what we are doing today, and then promote other things if we can, like leaflets, talks, videos, messages. So people in the country will get to know the factual basis of whatever the discussions that's taking place. Then we will also assess and use the logic with good backgrounds. I mean, as we know that if the background knowledge is not good, then whatever the logic we apply, the decisions will be not good as well. So we need good background knowledge to use logically or logically argue and assess and get better decisions. And that will make the decisions. So to try and make good judgments and decisions. So hopefully, if you follow this principle in our discussions all the time, it's possible that more people in the country will also start to think the same way, and hopefully we will start to move forward. So today, so here I'm quite interested for anyone who wants to speak. You can please come forward and propose topics of national interest, whatever that is, because we all don't know much of things. I'm a medic in background, so I don't know much of medicine either because it's such a big subject. Then I know a little bit about education, but education is so vast. So you need a lot of other people to come together to collect their expertise and experience to make a good judgment. And also please send comments and criticisms and corrections so we can improve ourselves as we go along. And we can speak, we're trying to speak in all three languages whenever we can. And so we'll start with English, but if people want to speak in Sinhalese or Tamil, they're welcome, but with subtitles maybe to start with so that everybody can understand. So if you have any of these things, you can write to this email, admin@srilankaleads.com. So today I thought I will present, I'm not an expert in the LPG gas, but when I saw this article, Sri Lanka's gas tragedy, the untold story, this was written by Dr. Desai Boteju. I think he said he would be in the audience today to add a bit more information at the end of the presentation that I'm trying to do as a layperson. So we know that we had an unexpected problem in Sri Lanka a couple of months ago, where the domestic gas cylinders started exploding, and there were some fatalities as well. But there were a lot of discussions and presentations and everything. And here is the conclusion: Sri Lanka's mysterious gas explosions become nobody's baby. So you can see the way we are handling issues are not really up to date or national friendly. Sad but it's true, but that is what's happened to most of our problems, and we don't find proper solutions to the problems, and therefore we actually start going down as a country, not really improve. So domestic gas explosions happened in LPG gas cylinders, liquid petroleum gas cylinders. And there were more than 400 reported within a week of this in December 2021. Many were injured and there were some fatalities. So later on, the government issued this statement, gas cylinder පුපුරන්නේ සංයුතිය වෙනස් කිරීමෙන්. So there was something to do with the composition of the gas that is in those cylinders. So why I got interested and I understood the article quite a while, because I use medical gases. And then, so this was a very good article that explained the whole story. So the liquid petroleum gas, in short called LPG, is derived during crude oil refining or natural gas processing. And there are byproducts generated during the production of liquid fuels, and these are the components, these byproducts are the components that forms the LPG gas. The key components of the typical LP gas would be propane and butane, but there are maybe other compounds there as well. And I will invite Dr. Boteju at the end of this to present more information about this. And depending on the refinery process or intended use, the LP gas can have a widely varying propane and butane composition. So it's a gas mixture that you have in these LPG cylinders. There's propane, there's butane. Now, propane, the boiling point of propane is -40. And that at that boiling point, above that temperature, well, that would be a gas. The boiling point of butane is -0.5 degrees centigrade. So at that point in atmospheric pressure, above that temperature, all that will be a gas as well. So, but the boiling point changes if you pressurize. So these are the boiling points that are there at normal atmospheric pressure, which is 1 bar. But however, if you look at propane, the saturated vapor pressure, which I will explain a little bit later on, is 124.5 pounds per square inch, which means 8 bar, roughly. That means 8 times the atmospheric pressure. Whereas the butane saturation vapor pressure is 31 pounds per square inch, which is 2 bar, roughly. So if you're using more propane, you need strict containment needs for safety, because normally this gas will have a higher saturated vapor pressure compared to butane. So butane is generally a safer gas, and it can be used in tropical climate as it does not become liquid at 1 atmospheric pressure. Okay, so let's take a little bit further and see. So the typical gas cylinders delivered in Sri Lanka, when full, 85% of that is liquid. How come then that has such a low boiling point becomes a liquid in these cylinders? This is because when it's pressurized, these gases become liquid. Here is an example that I can show you from our medical gases, so you'll understand it. See, oxygen, the critical temperature. The critical temperature means the below this, above this temperature, whatever the pressure you use, the oxygen cannot be liquefied. So you would have seen, liquid oxygen containers in hospitals. And these liquid containing oxygen will have to be kept at very low temperatures. Whereas nitrous oxide is also another gas that's used. Its critical temperature is 36.5, which means below this temperature, which is actually below the room temperature, these gases can be made liquid. So say here is an oxygen barrel. So you have a pressure gauge, and in normal room temperature, it will always be a gas. There's no liquid. So when it's empty, it's the pressure that will go down, and you will not see, you'll have to see from the pressure gauge that how much gas is left in there. But when the gas is liquid, the saturation vapor pressure will maintain this pressure inside. And when the cylinder empties, the pressure will remain the same right the way through until the liquid has completely evaporated. So there is a difference when you have liquid in pressurized states. So here is water, if you say. Normal evaporation, the vapor pressure is less than atmospheric pressure, so it evaporates. But when the vapor pressure gets equal to atmospheric pressure, then it's an equal state. So that's called the boiling point. Now, the vapor exerts a saturation vapor pressure. And the critical temperature I've explained to you. And let's go further down and see how this vapor pressure may have affected this problem. So I told you that the boiling point of a substance is the temperature at which the vapor pressure of a liquid equals the pressure surrounding the liquid, and the liquid changes to water. But this is atmospheric pressure dependent, this boiling point. So for example, if you take water, it will boil at 100 degrees centigrade at sea level. But you go to Pidurutharagala, right at the top of the mountain, at 6,250 feet, your boiling point comes down. So the water will boil at 93 degrees centigrade. So this is how the atmosphere, the temperature, the pressure within the cylinder can affect the safety of the gases that's contained. So let's compare the two compositions, okay? Now the propane-butane composition, normally it has been 80% butane, 20% propane. The equilibrium pressure in this mixed thing has been 53.6 pounds per square inch, which is about 3 bar, which is 3 times the atmospheric pressure. That's the composition that's been used in Sri Lanka for many years. And there has not been very significant problems. And that's probably because all the regulators and safety standards were designed and prepared and constructed for this operating pressure. So the 3 bar is the operating pressure that was constructed for. But if you put in 50% propane, equal concentrations like that, then the equilibrium pressure goes up within the cylinder to 89.4 pounds per square inch, which is a 6 bar. So it's virtually doubles. And when the pressure inside the cylinder virtually doubles, these regulators may not stand that, or they're not designed to stand that pressure. So leaks can happen. The new composition can do that. But in December, there was a problem. So this was something that was probably purposefully done because the gas prices, for example, in Europe, increases by 500% during December because of shortage. So whether this was done during that time for economic reasons, we don't know, but safety was obviously not tested before issuing it for public. So now these are kind of things that come into practice about consumer protection. So this table came from the article that I shown you, which was published in the island. And say the system committed cylinder. So the pressure increased, pressure virtually doubled in the LPG gas cylinders because the composition changed. So cylinder probably is likely to be safe, but cylinder valve could be unsafe. Now it's working at a higher pressure. So valve connection to the cylinder could be unsafe. The regulator connection to the valve could be unsafe. The regulator is unsafe, probably. Then the hoses and hose connections that we use at homes could be unsafe for these higher pressures. So the appliance and gas cookers probably unsafe because they're not really being designed to be used at higher pressures. So there was a major safety issue, which was maybe purposely ignored. If not, there would have been poor standards because there was no mechanism to change or test a change in the composition of a compound that is publicly used. And maybe the people were not aware of the risk. Maybe there was poor application of the regulations. Maybe there was poor testing. Maybe it was an economically driven public unawareness, or issue is unknown or kept secret. But whatever it is, then there's something called hazard and operability hazard studies that needs to ensure these standards. So I'm not an expert, but I thought it's important that I welcome maybe Dr. Boteges is around to take a few words if you're around. Yeah, I don't know.
Yes, I'm here. Can you hear me?
Okay. Oh, thanks very much for coming along. I hope I kind of explained a little bit for people to understand in very simple terms. So,
Very good.
you can say a little bit more about it and see how maybe developed countries improve the safety standards and so on.
Yeah, I think Dr. Chulanand, what you have been presenting is really good. I don't have many comments on that, but I can take few extra words regarding surrounding facts here. The thing is that, of course, this what you are showing here, this hazards and operability study, or what we normally call HACCP study, it's a key thing, key safety management thing we need to do whenever we do a certain change to a process or a operating procedure or a product. That's a fundamental thing. Even undergraduate student of process engineering can explain this. That is a fundamental thing you learn in your university, in your career, and you have to practice. These are fundamental things, not any sophisticated technical things. This is very normal for an engineering student. So if you do this kind of a particular thing, HACCP, or even you have something called HAZID. HAZID means even simpler study, that's called hazard identification study. That is even simpler than HACCP, because HACCP is something you do to a process based on what we call piping and instrumentation diagram. That's the whole diagram indicating your process, whether it is a gas or liquid, fuel, soap manufacturing, any process you have a this PNI, this piping and instrument diagram. So this HACCP study is done by using those kind of technical things. But for any other thing, even before doing a HACCP, you can do certain thing called hazard identification study. That is a very simple study. Basically, what you do is that you basically go through your whole process, because you need to have some kind of sketch on your process, and then as a brainstorming study in a workshop gathering, you discuss, everybody discuss the potential hazards, risk, the safety barriers, and remaining risk, and what additional safety barriers you need to implement. For example, if this is if you are thinking about this thing, changing of the composition, let's say that's the argument here. You change the composition of the gas cylinder. Then what you call is that, what you should do that you gather all the relevant expertise into a workshop gathering. For example, you can call for process engineers, electrical engineers, managers, safety managers, and even workers, some representative of the plant workers, or let's say technicians. You gather everybody and present your case very clearly. The current situation is we have 20% 20% propane and 80% 80% butane and 20% propane. Now we are going to change this to 50-50. Now the floor is open. Please express your opinion. What's going to happen? That's the baseline of a hazard study, even before going to a HAZOP. Then everybody can see what's going to happen. Then somebody can start talking about the gas cylinder, like I am talking. You have been showing here. Then somebody can start talking about what happens to the cylinder valve. Then somebody asks what is going to happen to the regulator now. And somebody asks what is going to happen to the appliances. Then all these things will discussed step by step, and then everybody can understand the potential repercussions of this change. Once you understand that repercussion, then you understand the whole risk picture. Once you understand the risk picture, then you can think about what additional safety barriers are needed and what safety barriers are already in place. For example, somebody can tell, okay, we have this pressure regulator. So even if you increase the cylinder pressure, since we have this pressure regulator, then we have a safety barrier. That one person can tell that. Okay, then everybody understand we have a safety barrier, that's the pressure regulator. Because pressure regulator means to regulate the pressure coming from the cylinder. Then somebody asks, why can't we increase the pressure to whatever value we need? Then some people need to think about, okay, let's go into the design of the pressure regulator. Every pressure regulator is designed for a certain design pressure range. For example, I have noted that most of the pressure regulators used in Sri Lanka, even the best ones used in Sri Lanka, if you go to your pressure regulator today, and you can clearly see the design pressure marked on the pressure regulator. Even the best ones basically indicate 7.5 bar. Those are the best ones used in Sri Lanka. But I have seen many pressure regulators, they say 6 bar. And even some, actually some of my friends told me they have seen some pressure regulators used in Sri Lanka, just say 5 bar. Now, the situation is that is the maximum inlet pressure, the design value. But then, like Dr. Chulanand explained here, if when you increase the pressure of this, when you change the composition to 50-50, that can easily go beyond 6 bar pressure, even at a temperature of 32 degrees. But you know that in many of these roadside shops, hopper huts, in the restaurants, due to this space limitation, they keep their cylinder very close to the gas cooker. Sometimes I have seen they just keep the cylinder below your gas cooker, and people working with sweating and a lot of temperature, not even ventilation. So they work under harsh conditions, and the temperature can easily exceed 35 degrees. It can go even 40 because they don't care. They just work like hell. So that means even the surrounding ambient temperature experienced by the cylinder can easily exceed 35 degrees in certain settings. So now you can see at 35 degrees, let's say, if you exceed 35, the pressure can very well exceed 7 bar, because according to what I remember, at 38.2 degrees, see, that's exactly the 100 Fahrenheit. Because normally they specify these values at 100 Fahrenheit according to the American standards, that equal to 38.2 degrees centigrade. At that temperature, 50-50 cylinder, 50 propane, 50% butane cylinder pressure, the equilibrium pressure can be around 7.2 bar. So even if you have very good regulator designed for 7.5 bar, now you are very close to the design margin. now we have to remember, even when you are thinking about the design pressure, that doesn't exactly mean that we should operate it close to the design pressure. That's the maximum margin. We should always try to have a good enough margin, safe margin below safety, the design pressure. So it might work at 7.2, but the thing is, now we are very, very close. Now, if you think about another regulator, very cheaper regulator, where it is designed for 5 or 6 bar, now we are in an unsafe limit. Unsafe limit. Actually, if you have time, I can show you how this pressure regulator works. It's based on some diaphragm arrangement, and then even this diaphragm can rupture if the pressure increases, inlet pressure. So a lot of things can happen. And also this pressure regulator is sealed with some nuts. They are all designed for this maximum pressure. Once you exceed the maximum pressure, everything can start leaking, because they don't have pressure integrity against that beyond that maximum design pressure. So even the regulator can leak, the diaphragm, the control diaphragm can rupture, and even any of those not happening, still the regulated pressure out of the regulator will increase beyond the regulated limit. We should understand that these cookers or appliances basically used in Sri Lanka, they normally should have inlet gas pressure of around 30 millibar. Remember that we only need a very small pressure going into the appliance, because they are burners. They cannot burn a lot of gas at once. That's what they are designed for. These are not big industrial burners. These are gas cookers used for the cooking appliances. So they only need very small gas rate, around 30 millibar, 29, 30 millibar. That's all they want. So if we start sending more gas than that to the cooker, let's say we increase it to 50 millibar, because now we are exceeding the regulated, the design maximum pressure, and the flow will now increase beyond that 30 millibar control pressure. Now we are sending more gas to the cooker, then the burner is simply not designed to burn this much of gas. Then what happens is that lot of unburnt LPG gas will escape, and those escaping gas will accumulate around, and immediately they can burn, either burn, or if you have enough concentration, that can explode. So that's why we are seeing a lot of this gas cooker explosion. And also we are seeing many regulator side explosion, the explosions happening and the leak and explosions happening on the regulator, due to the same reason I explained. So all these things could have been very easily identified if we did a hazard or a HACCP study, because that is the intention of hazard and HACCP. They simply did not do that, then nobody identified this. This is the fundamental thing. Of course, I can go beyond, but due to the time limitation, I will stop at that point. So, Dr. Chulananda, you
Yeah.
continue. That's a brief explanation from me. Yeah.
I think it's very good telling us about the how the small change in the pressure within the cylinder can cause such a big problem, because the standardization is not suitable for that increased pressure. That's basically the problem, isn't it? So obviously, now I just want to go down a little bit further and see how would a developed country handle this kind of a problem, so that we understand how people might work in there. So if there was a problem like this in a developed country, for example, you'll have immediate attention to victims. That's what their injuries, because the life matters and the life is valuable. And then they will take care of the injured people, provide support staff, provide facility for dependents, etc. Then they will ensure safety in the area. So to do that, they might withdraw all kind of gas that was issued, refund all the money that people have paid for it, and then establish safety. But obviously, this kind of thing, when they withdraw, there's a big problem where people are so dependent on gases for their cooking and everything else. So people or the government will try to find alternative methods of supplying energy for them, so that this can take place. If it's impossible, then you can use safety guidelines, how to use these things, maybe completely outside the house or something like that, until the problem is resolved. So these are kind of short-term things that a developed country might do when there's a disaster like this. And they will obviously, create an independent root cause investigation that could even be a public inquiry and collect all the data from people who are affected and say, I listen to their stories and find exactly what has happened. So in the long term, then we should try to fix the root cause. As Dr. Bhattacharya was telling, there's a problem of the regulators that is in the market. There's a problem of the pipes, even the modification of the gas burners may be required. So fix the root cause and the legislation to prevent recurrence of this issue, because now we don't know why this has happened, because was there a leak? Was there a kind of weakness in the regulation where you can change the composition of the gas without testing in the country? Was that possible? If that's the case, shouldn't the regulation will be reviewed and sorted out? Then enhance the safety regulation mechanisms. Consumer protection down here comes first. Then retrain staff. If the staff who were doing these regulations were ignorant of this, then retrain them and retrain the consumer how to use it safely, issue more guidelines, etc. And the legal punishment or for any malpractice comes as well, but that's not the priority, because what matters is to look after people, find the problem, fix the problem. And if it's a malicious intent, somebody has done something like this, or have completely ignored the rules that are in existence, then this should be a legally, proposed or managed punishment process, because otherwise we'll never improve as a country. So this was a good example where we could use what has happened to learn from it and then improve ourselves for the future. So if we had done these things, a similar thing happening from something else could prevent. So what we need here is you have to have consolidate national accountability, which was kind of weak in here, and promote a safety culture. So promoting a safety culture, you can't really blame an individual. I mean, in a sense, nationally, we should have a enhanced safety culture through understanding, to regular teaching, etc. So to improve this kind of situation has to come from the people for the people. So we do have to be more aware of the safety things and then talk about these things, and then get the people who are responsible to implement or update the regulations as necessary. So I think we come to the end of this talk. So I was trying to kind of limit this discussion to 1 hour, so because it's Sunday evening time for everybody, but I'm prepared to allow you all to put questions on. I mean, if you want, you can raise your hand or you can just speak. You have to unmute yourself if you're speaking. Anything else you want to say? Anything else from the audience? Any suggestions, questions? Okay, so I'm going to make an edited version of this available through the internet so that people can refer to it in the future. And I would welcome anyone to send us suggestions, comments, or if you want to speak on a subject. There's so many things that Sri Lanka needs improving, and there are so many things that we can talk about, whether it's water conservation, whether it's agro-modernization, whether it's ethics, whether it's safety, then corruption, many things you can talk about. So I hope the experts who are around can come forward and talk to us on these. Very short, very simple, that's what we want. And so that it will become a public education exercise. So I hope we'll be able to go forward like this. Thank you, Dr. Bhattacharya, for joining us and then explaining a little bit more about this. And any other comments, questions from anybody else around there?
Good evening. I don't know where everybody is, but it's morning for me. But I think Chula, are you still in Sri Lanka?
No, no, I'm in the other end of the world at the moment. But anyway,
Okay.
but I thought I'll
Uh,
have to start this.
so very interesting presentation from you, and thank you, Dr. Boteju. So the essentially this points to the gas mishaps were responsibility of the people who knowingly or unknowingly distributed gas cylinders. I have an experience with gas cylinder way back when in 1982. Actually, I was transporting one of the gas cylinders. It started leaking, and this was, probably I didn't know anything about gas, combustion or anything. It's LPG, liquid propane. We knew about that, but I didn't know the composition, whatever it is. But the main issue is that in Sri Lanka, the everything is controlled by whatever the you have to put what do you call epithet, but it ends up with the last name is mafia. Okay, there's a gas mafia, grain mafia, rice mafia, or you name it. Just before this meeting, I was talking to one of my friends who was going to start a compost project, and there's a compost mafia too. So the problem is that the last time, so you mentioned few topics, and corruption is, I think, the main issue. I think Sri Lanka is world's most corrupted country so far. I think even it goes even beyond Uganda and Ethiopia and all those countries who used to be corrupted. And that's what I see from my experience and trying to deal with people, and because they don't want to do anything without getting a commission. So that's why the problems are not solved in Sri Lanka, because from peon to secretary of a ministry to ministers, they all want a cut from some cheap import.
Yeah, I
Because
think
I have first-hand experience in trying to deal with some of those. So how do we add? I mean, this groups uh, aim or charter is to
it
address this
yeah,
issue. But
I think
how do
uh,
you address those things?
yeah, I think it will come to light with if we start using the kind of principle that I mentioned as leads. Why we call leads means
Yeah,
we learn and then discuss and then make a decision. I think
yeah,
when the public expectations go up and up and up,
yeah,
then the thing starts to improve. Unfortunately, the in the political setup in Sri Lanka for last 3 or 4 decades, the people who can really make a contribution to it distance themselves. They were not doing anything. They left. Most of them left the country because they didn't. They were not bothering to fight back. But if you were, I mean, if you lived in a developed country, I mean, you will know what the situation is like. I mean, you get a kind of a tile lifted up in the public footpath, and they will complain about it and then ask for compensation. For example, if it's in London, so 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 that's the kind of public acceptance that is there is. So if the public gets to know the reality of things, then they will not accept these things as normal that cannot be corrected, or say mafia. So that is what we are trying to do. So we can try to do this, improve the public knowledge and their understanding, and then they will make the decisions for everybody as we go. So we can only try. I hope it will be successful, very peacefully, and just fact finding. We are not trying to find blame with anybody. We are trying to see how things can improve. That's why I actually put an outline how a gas explosion kind of story will be handled in a developed country, so that people will say, oh, there's another new way of people handling this. So then They think about, oh, shall we do this? Because there's a lot of, I mean, if you go into any country, there's a lot of good people in those countries. There are a lot of bad people as well, whether it's developed or developing or whatever. You have enough corrupt people in other ends as well, but they cannot exceed a certain limit because of the regulations and awareness and everything else. So this is what we are trying to do. Let's see whether it will proceed. So I would like you to welcome you to come and talk sometime, a small topic, anything that you want to talk about. Just, follow the principle of leads and just say what you want to say. That's all. And that will take a long way.
Okay,
Perhaps,
thank you, Dula.
yeah, I have maybe a proposal. For example, we can talk a little bit about this Express Pearl accident, because I have been present in many times now. So I have a lot of material. If you want, I can briefly talk one of these days later on about the Express Pearl accident.
Just send me an email, your title and the date that you can do it. So we can do that. And if you have any friends who can talk about different subjects, because I mean, for example, I've been in medicine for 40 years. I don't talk about any other specialty because they are so different, so much advanced. I'm sure in your own subject areas, there'll be so many subspecialties where others can offer, better advice. So this is what we need. So we need to learn from each other, present it. And we're not going to waste this discussion, because this will be online, and I'll tell you where it will be very soon. And then anybody can look at it. So what we need is, it will probably take an year for people to start to look at it and then go for it. It's just like, when Wikipedia started, nobody looked at it, but now everyone wants to look at it. It was a voluntary, simple program. So likewise, we'll be able to give good information for Sri Lankans so that they might make better decisions in whatever they're doing. So thank you everybody for joining. Yes.
Dr. Chulananda,
yes.
May I be permitted to ask two questions?
Yes.
Either from you or Dr. Boteju.
Yeah.
Yeah, good evening. I am Jampati Molligoda from Sri Lanka.
Yeah.
I would like Dr. Boteju to clarify one thing. As a layman, I don't have any knowledge about it. As a layman, I joined a team who wanted to study this further. And I noticed from the recent standard, apparently the standard has been revised recently, that is the SLS 712 2021 from 1998 first revision. According to that standard, the vapor pressure at 37.8 has been revised to 637 kPa from 1700 odd as per the previous standard. And also the second question is the combination, the composition of butane and propane. The propane, the percentage has been limited to 30%. The earlier there was no standard for the composition. I mean the previous 712 1998 first revision. Now, with the recent revision effective from 20th December, the propane percentage has been reduced to maximum 30%. In other words, the balance with all the other little things, the butane is little less than 70%. So I got the impression that we are under the impression that we are working towards 50-50. But according to this one, my understanding is it's maximum 30%. So those two, if you can kindly clarify. Thank you.
Yeah, of course, I can answer that. So you are basically telling that in December, Sri Lanka has amended their standards. I know, actually, I knew that we never had any particular standard specifying the composition. So now you are telling that they have made a standard. That's also news to me. So Mr. Kure, do you confirm that in December they have amended the standard?
It's
not amended, but made the standard. So, okay, yeah. But what I'm going to show you is that I can actually show you one thing. I can show you the Okay, Mr. Chulanand, can you enable screen sharing? I want to show you.
Yeah,
Show
I
you
think you
something.
can do the screen sharing. You should be able to.
No, it
Let
says
me-
host disabled participant screen share.
hang on. I'll see. It should be able to.
Yeah,
That's probably because my screen is there. Shall I take that off? And then
No,
you-
it should be okay. We can, yeah, maybe. Okay.
maybe
yeah.
that's why.
Chula, you need to give him make him a co-host.
Yeah, I'll try. I'm trying.
Okay.
I'm trying. All right.
Yes,
Okay.
it says host disabled. Yeah.
Yeah. Okay. Now you're co-host. Yeah, you can do that. Yeah.
Now I'm going to share something. Okay, let's see this is screen. Okay. So soon you should see my screen. Just let me know when you see it. You see any screen?
Not yet. No,
Not yet. Okay.
it will take a little
Okay.
time.
Okay. I have to just say share. Okay. Now you should maybe see in my screen.
Yeah.
I've seen it. Yeah.
Yeah.
Do you see a table with the
Yeah,
values?
we
So
see a
okay,
table.
good. Right. So you are seeing my screen. So this is basically a equilibrium pressure table for different composition of propane and butane. So as Mr. Kure said, if now the standard is 30% propane and 70% butane, so now we can go down this column and then under 100 Fahrenheit or 37.8 degrees. The equilibrium, the total, the pressure inside the head space of the cylinder will be 70, around almost 80 PSIG. So that's what we will have. So for the moment, if you use a 50-50, that means we are now talking about 105 PSIG. That's the value we should expect when they change the composition. And previously it was 64.4, under 20% and 18. Actually, the thing is that nominally we said previously our concentration was 20% propane and 80% butane, but I know that has been kind of a flexible range even before. Normally the specification or the situation was that the propane was in between 20 to 30 and the butane was 80 to 70. So I think specification of this standard is progressive step, but that is not the only thing we should do, because you know what, in many of these European countries, actually we even use 100% propane. That's no problem. So, right. So I can even show you one thing that I just got into just a little presentation mode, because I wanted to show you this one. So I get to my screen. You see my presentation?
Yeah. You can.
Okay. So, okay, I will show you this one. If you look at here, this is a picture sent by one of my friends living in Sri Lanka. He was kind of boasting that he had the best regulator in the country. And then I can see that is specified for 7.5 bar. That's what I said. Even some of the best regulators sold in Sri Lanka, they are basically rated for maximum about 7.5 bar. That is the maximum inlet pressure. But you know what? Then what I did was that here in Norway, I just went to a hardware shop and just look at a typical regulator. This is what I found. I have to tell you one thing. In Norway, we produce a lot of gases and petroleum, but we never use gas at ordinary houses for any purpose under normal circumstances. I will tell you what we are using the gas, but normally we don't use gas for cooking. We don't use gas for heating. Basically, all gases produced here in Norway, we ship out through the gas lines to other European countries to be used. That's what we do. Or the remaining gas, we send back to the reservoir, the oil reservoir, so that we can use that gas to pressurize the reservoir and increase the oil yield. Because here, when we produce oil, actually for any country producing oil, gas is not the most common thing, most important thing, or the most valuable thing. The oil values more. So normally, actually, we really like to have reduced amount of gas and more oil. So most of the time, the produced gas is injected back to the reservoir so that we can increase the pressure and get more oil. So that's an extra point. So in Norway, what we do is that we never use gas for normal cooking or heating purposes. I think only very few people use who are particularly stingy about their electricity bill. Otherwise, we don't use. But we do use gas for especially in the summer for our gas grills. That's what we do. So what we do is we put our gas cylinder outside only during summer when we use our gas grills. That's the most common place people use gas, not for any other purpose. So that means we do have regulators to be sold in the hardware shops. That's what I found this regulator. You see, you can see this is the cheapest kind of regulator you find here in Norway, in any shop. And you can see the inlet pressure range is 0.3 to 16 bar. Now you can see the difference here and the part of the problem Sri Lanka experiencing. Here we use this 16 bar as the maximum inlet pressure. That means we can use this regulator even for 100% propane, because at 100 Fahrenheit or 38.2 degrees centigrade, even at that temperature, the equilibrium pressure of 100 bar, actually you can see it here clearly, 100% propane, what's the pressure? 38.2, so 172. This is actually basically close to around 11.8 bar. That means it is below 12 bar. That's actually part of the problem, you can see. So if you want to increase your propane concentration, then you have to have your infrastructure ready for that. That's the thing went wrong for Sri Lanka. We increase for whatever reason. It is highly likely that they did it for economic reasons or the reason of finding gas, because these days, like Chulananda said, it's quite expensive, the gases, and also finding gas supply shipments is a bit difficult. So they went for whatever the available propane they have, but they didn't think about the infrastructure. That's part of the problem. So to answer Mr. Kure's question, I think having this standard is good thing, but that's not sufficient. We still have to put attention to our infrastructure, because in an ideal case, if we had really good regulators, infrastructure, and the gas supply system domestically, we would not have had this problem. So even if you think about this cylinder leaking, you can see many cylinders were leaking. Why is that? It should never have happened, because even at this concentration, this should not have happened, because this valve on top of the cylinder, that must have proper integrity, even if you have 100% propane, because concentration change will not make an excuse for leaking cylinders. Cylinder should not have leaked even under that situation. What happened was that they never, apparently nobody change out these cylinder valves regularly, because these cylinder valves are not meant for using forever. That's not the case, especially when you put this regulator cap into the cylinder valve. There is some gasket, and also that wears out, and also the valve wears out. So all the things, they have a design life. Normally, I think this valve need to be changed from the cylinder every 5 years or less. So that might not have happened. And also you need to change out this rubber sealing on the regulator cap. That looks like it is also not being done very often. So all those things come into the picture. So to answer Mr. Kure, those things must also be addressed. The maintenance program and the integrity of the whole pressure protection system, the pressure integrity system, that needs to be addressed. Otherwise, just changing something on a letter or something on a standard will not do anything. That will help, but that is not the whole picture. That's my answer. If you have any, if my answer is not good enough, just let me, I can explain more, but I don't want to take a lot of time.
Yeah, it was Mr. Molligoda who was asking the question.
Okay, Mr. Molligoda. Sorry, I'm very sorry.
Thank you. Thank you. No, thank you so much. Yeah, thank you. Actually, just to comment on that, I'm told by this committee that in Sri Lanka, most of the regulators are inferior quality, and it's 6 bar. I don't know. They say
right.
Yeah, and also they mentioned that this maximum vapor pressure has now been reduced from 1430 APA to 637 under this new standard, and they foresee some problems in the industries like confectionery, ceramics, and rubber. They find it difficult to run their systems, it seems. And also, the company claims that a good quality domestic regulator is designed to handle even a pressure of 1600, and they wanted them to reconsider this reduction in the vapor pressure to 637. And as I said, under the new standard, the maximum propane has been reduced to 30%. So in the new tender, by the way, this is on a 2-year tender, and the tender specifications and the shipments are somewhat in compliance to the standards. And now they wanted to change the, in compliance with the new standard, they want to have a standard to say that the propane has to be 20 to 30 or 22 to 30. Sorry, 22 to 28, because they don't want to have a issue with regard to exceeding this 30. There's no plus or minus also they have given it. So that's the latest I heard. So there will be a tender floated for the next 1 year going up to March. So this tender will last only up to 28th of February. Thank you.
Yeah, great. Yeah, so my purpose was try to make public understands the relevance of the regulator even, you see. So, I mean, it's good that somebody is trying to improve the regulation and control. But if the valve is the problem, then as Mr. Boteju said that, you know, the valves can be improved. So that will suddenly give you a better safety margin for everybody at home. And unless the people know that, you know, what to look for in the valves, then nobody will know what a safe valve will be. They just have to depend on whoever it's marketing. So this is why I think, you know, this kind of discussion will be more helpful widely. And then with time, people will start to refer to what's been discussed. So may I thank you all for being here today. And then I'm trying to make it very short meetings so that you know, you don't waste time. So start sharp on time and finish within 1 to 1.5 hours. And if you want to speak on something, please do send me your title. And I'm very interested to promote that kind of discussion. So Mr. Mulligada, I think you are in tea industry, and tea is such a wonderful thing for Sri Lanka. And, you know, Ceylon tea is a name that's been taken, but unfortunately it is waning off in other countries for whatever the reason. And it's something that we need to talk about probably at some point.
I'll do that. Thank you. Thank you.
All right. Okay, great. Have a nice
Okay, thank you very
evening.
much. Thank you very much. Thank you. Bye bye.
Thank you. Okay.
Thank you.
Bye.
Thank you.